The Heller 5-axis machining center HF5500 with mill turn is a state-of-the-art machine tool designed for dynamic and productive machining. The HF5500 boasts a horizontal spindle that travels along the X and Y axis. A trunnion table with rotary A and B axes allows for precise positioning and manipulation of the workpiece in all directions, 360 degrees. This enables simultaneous 5-axis machining, where all 5 axes, X, Y, Z, A, and B, move concurrently to create intricate features on the workpiece. The machine features a swiveling NC rotary table with counterbearing and AB kinematics with highly dynamic torque drives as standard. The HF5500 model has an option for mill turn, which is a combination of milling and turning. This optional feature on the HF5500 essentially combines milling and turning capabilities within a single machine. Milling involves using rotary cutting tools to remove material from the workpiece. Turning utilizes a rotating tool and the workpiece itself spinning to create cylindrical or conical shapes. With mill turn, the HF5500 can perform both these operations on the same machine, eliminating the need for separate machines and setups, saving time and improving efficiency. The HF5500 is designed for maximum productivity with short idle times, quick NC tool changer, and highest axis speed with equipment packages Speed and Pro. It also provides optimum accessibility for simple operation and maintenance. The main operating unit is designed as a console with a 24-inch multi-touch screen and Heller operation interface. In summary, the HF5500 is a highly productive and flexible machine that allows for a wide range of tasks to be handled on a single machine. It's a perfect solution for both series production and workshop-based production. The heavy-duty face lathe machine is designed to process large and heavy workpieces such as a rotor shaft. The raw rotor shaft, made from forged steel or other high-strength material, is securely mounted between the lathe centers or in a chuck depending on the shaft size and features. The lathe starts with roughing cuts using a cutting tool to remove excess material and bring the shaft closer to its final dimensions. This initial cutting might involve high feed rates to remove material quickly. With the roughing complete, the lathe transitions to turning operations. The cutting tool is positioned to create the desired cylindrical or conical shapes on the rotor shaft. This may involve multiple passes with the tool to achieve precise diameters and tapers. The facing operation involves the tool moving parallel to the axis of the shaft to create flat surfaces on the ends of the rotor. After achieving the basic shapes, finishing cuts are performed with finer cutting tools to achieve the final dimensional tolerances and surface finish required for the rotor. A lathe machine and a milling machine are both used for machining, but they have different working principles and are used for different types of operations. In a lathe machine, the workpiece spins while the cutting tool stays still. It is primarily used for machining cylindrical parts. The cutting tools stay stationary, and the metal or wood object is rotated to make various shapes. The chuck on the headstock holds the workpiece and rotates it continuously, and the tool holder holds the cutting tool, which is tightened really carefully so that it can't move. It is mainly used for operations like turning, thread cutting, facing, counterboring, boring, drilling, reaming, spot facing, sanding, cutting, knurling, and chamfering. Meanwhile, in a milling machine, the cutting tool rotates and the workpiece stays still. It can be used for machining both flat and curved surfaces. The cutter is placed on a spindle or arbor, and it can rotate at high speed. The workpiece is held in the table of the machine. The movement of the table controls the feed of the workpiece. It is used for operations like facing, side milling, plane milling, saw milling, milling keyways, grooves, slots, and threading. The Hermel C42U Dynamic Machining Center with 5-axis configuration is a powerful tool for machining bevel gears. The machine operates in a 5-axis configuration, which allows for complex geometries like a bevel gear to be machined in a single setup. The C42U dynamic model combines milling and turning in one clamping. This means the machine can perform both operations without needing to reposition the workpiece, ensuring high precision and efficiency. The workpiece is clamped using a hydraulic Stark 0-point clamping system. This provides a secure hold on the workpiece during the machining process. The bevel gear blank is securely mounted on the C42U Dynamics trunnion table. A computer-aided manufacturing (CAM) program translates the bevel gear's design into specific toolpath instructions for the machine's controller. The machine follows the CAM program, with the 5-axis functionality allowing the cutting tool to reach all the necessary surfaces of the bevel gear teeth. The machining process might involve roughing cuts to remove the bulk of the material, followed by finishing cuts for achieving the final tooth profile and surface quality. A CNC double-column vertical lathe is a type of machine tool that is used for precise and complex machining tasks. Unlike traditional lathes, the double-column configuration provides enhanced stability and rigidity, allowing for unparalleled precision in machining. The workpiece is held vertically, which can be beneficial for machining large or heavy parts. The machine uses a rotating cutting tool to remove material from the workpiece. The cutting tool can move in multiple directions, allowing for complex shapes and features to be machined. The machine can automatically change tools, allowing for different machining operations to be performed without manual intervention. The Heller HD i6 crankshaft machining process involves a series of steps that are designed to produce high-quality crankshafts. The HD i6 crankshaft is machined by internal milling. This process involves the use of a milling cutter that rotates within the workpiece to remove material. During the machining process, radial orientation is maintained via a steady rest. This helps to ensure the accuracy and precision of the machining process. The initial stage of the machining process involves rough cutting of the HD i6 crankshafts. This is where the bulk of the material is removed from the workpiece. The machining process also involves the machining of 5 main bearings and 6 pin bearings in one setup. This helps to ensure the accuracy and precision of the machining process.